So just a quick video on solving by square rooting and just as a review and by factoring. So I want you to review these notes that we took and notice that we had four methods, but really you'll only probably use the first three. If you have no bx term or if it's in vertex form, you're going to solve by square rooting. And we have an example in our notes of that. I'll put in an example today of how to solve in vertex form. If you have a bx term, then we can try star factoring. As long as it's factorable, that will work and probably be the preferred method. We're not going to talk about quadratic formula until the future, probably towards the end of the unit, so don't worry about that method at this point. Okay, we saw in this example note, we had one where there was no bx term, so our goal was to get the squared term alone, and from there, and sometimes that takes multiple steps, from there, our goal was to square root, and remember that a square root has a positive and a negative version of the same thing, so a positive and negative square root. Okay, so let's look at one. In fact, let me change the order of this a little and do one with vertex form. So here we're given a vertex form equation for a parabola, and we're asked to solve. Solve again means find the x-intercepts, or the zeros of this parabola, like where does it cross the x-axis. So step one is to set the function equal to 0, which means the function becomes 0 in other words, f of x is 0. Okay, step two is to get that squared term, just like square rooting in the previous example. Get the squared term alone, so we worked to get x squared by itself. In this case, it's the same idea, only now we have x plus 8 squared. So we want to get the whole thing that's being squared by itself. Okay, so for this one, we're going to add 72. And we need to divide by that 2 to get the parentheses squared by itself. So we get 36 equals x plus 8 squared. Okay, you may not distribute the 2, so you can't do that because of the squared, so that would break order of operations, so please don't do that. And also we can't subtract an 8, like right here I can't subtract 8 out. That would also break order of operations. So this way that I'm showing you is the only way to do this correctly. Okay, at this point, just like before, we're going to square root both sides. Don't square root both sides until the parentheses squared are by themselves. Don't square root until that's true. Okay, so we're square rooting. Square root of 36 is plus 6, or positive 6, but also negative 6. It's both. Okay, and then on the other side, square root of x plus 8 squared is x plus 8. So we're pretty close to done. Now we get x by itself. And actually, before I write that, let me remind you, don't forget both positive and negative. Okay. Then we go ahead and solve for x like usual. So solve for x or get it by itself. But what this actually means is we're going to subtract 8, subtract 8. But what that means is we're going to have negative 8 taking away from 6, so positive 6, but also negative 6. So it's both. Solve for x with both positive and negative values. Okay, so the positive 6 minus 8, that would give negative 2. And then the negative 6 minus 8 would give negative 14. So we have two answers, just like we've seen with quadratics. That parabola can cross up to 2 times. So just a quick reminder, if it looks like that, it crosses twice. So we can have two answers. That's this case. If it just comes in and just bumps off of the x-axis, or maybe from below and just bumps off the x-axis, we'll only have one solution, or 1, 0. And then of course we can have the situation where it doesn't cross at all, and we'll cover that later on in this unit where we'll have to use imaginary numbers. Okay, so we've seen now the case. Let me go back to the note. We've seen an example of no bx term or in vertex form, and how to use the square root method to solve in both cases. Let's look now at the second one, number 2, if we have a bx term and it's factorable. Okay, so go ahead and write this down. Solving by factoring this time. Okay? So you should immediately, when you look at this, you should see a bx term. So when you see a bx term, we want to try factoring it. Okay? But before we do that, we need to set, I don't like the word set for this, let's say get it equal to 0 first. So in order to do that, I need to get this 4k squared off of the right side. I will give you a little advice. Keep the x squared term positive. You'll make less mistakes in your factoring if you keep x squared positive. Okay? In other words, I wouldn't want to subtract the 5k squared like this, because now I'm making over here I would get negative k squared, and students just generally make more errors that way. So don't do that. And also be careful with combining your like terms. So I can't combine k squared with k's or with the 18. It has to stick with its like kind. Okay, so 5k squared minus k squared is k squared. And then we have the rest of this stuff. Then it's equal to 0. So get it equal to 0 first. And then next step, we're going to set up our star. We took notes on star factoring, so let's, in your notes already if you need to remember that. Okay. And for the star, we need A, C, and B. So A times C, and if you need to write it out, that's fine. A equals 1, B equals negative 9, don't miss the negative, and C equals 18. So A times C is negative 18, B is negative 9, and A in this case is 1. So we need to find factors of negative 18 that add up to negative 9. And remember, factors are what is multiplying what multiplies to make negative 18. So factors of negative 18 that add to negative 9. Well, that's going to be negative 6 and negative 3. And if you get stuck on that, remember you can always just make a list, like 1 times 18, you can't make 9 with that. 2 times 9, we can't make 9 with that. And then you get to 3 times 6, and that one works. Alright, keeping in mind as we do the star that you should reduce these fractions if possible. In this case, they're already reduced, so we don't need to worry about that. But just don't forget to do that. And then in these, the top number goes with x, and the bottom number, just copy the sign down. Top number is 1, so x, bottom number, copy the sign down. That is still equal to 0, as we've just rewritten it in a different form. Okay, so step 3, set up the star and factor. So now we're here at the factored form, and we're still trying to find those zeros. So step 4 is to set each factor equal to 0 and solve for each x. So we did this when we did absolute value solving, where we had to split and solve twice, and this is very similar to that. So maybe just kind of make a line down the middle, and basically what we're saying is if two things are being multiplied and equal 0, then one of them is 0, maybe both. So let's check where that happens. So we set x minus 6 equal to 0 and x minus 3 equal to 0, and then just solve those little mini equations. So on this left one, we're just going to add 6. On this right one, we'll add 3. And it's like the easiest solving at this point that you've ever done, because it's just usually like 1 to 2 steps. So in this case, we find out that x can be 6 or 3 to make this whole thing be 0, which tells us, if we're relating this back to a graph, this parabola is opening up, it's vertically stretched. Technically, when we simplify, it's not stretched anymore, but anyway, and we have one of these is at 3 and one of these is at 6. That's what that whole thing is telling us. Okay, so that covers the first 2 methods and ones that we will use fairly commonly, so square rooting and solving by factoring. In your packet, you will see, let me show you what you'll be looking at. I'll come back to this just in a second. So some of this is extra, like you don't necessarily need to read all this stuff on the side. So first you'll start by factoring and just practicing that, and then we start talking about a GCF. So remember, we talked about when you do the star, you need to pull out any GCF first. So like this first one, I see that each term is divisible by 2. So I'll divide that out front and then put the leftovers inside. Okay? Remember that this factored out version has to be able to be multiplied and recreate the original version again. So don't forget to put your 2. Okay, and then we'll take that piece and do the star just on the inside. And so a times c is negative 21, b is negative 4, and a is 1. So we're looking for factors of negative 21 that add up to negative 4. And you can go through your list. 2 doesn't work. 3 and 7. Oh, hey, 3 and 7 can make 4. Okay, be careful with your sign. We want negative 4, so 7 has to be negative. And then check to see if those can be reduced. In this case, they cannot. So then write your factors out. Okay, but don't forget this 2 has to come out front, because it was one of the factors at the beginning. And to solve, like we just saw in the previous example, to solve, we would split this and just set each piece equal to 0 and solve from there. So this will become -3, this will become 7. So that would be our two solutions to that if we were solving for the zeros of that function. Okay, sometimes students get confused when it's solving in this kind of mode. I just want you to know this would be 30p squared plus 21p. And then we just GCF factor out a 3p. But this is still the same situation as these kind. By the way, these kind are already factored for you. So you just do your split, set each one equal to 0, and solve each piece. Okay, that's like a shortened version of what I've just shown you. But students often get confused when it looks like this. So GCF, meaning pull out the greatest common factor, which in this case is 3p. 3p and 3p, we divide both sides and pull it out front. But once you're there, it's still just the split thing. It's before I do that, it's two things being multiplied that make 0. So one of them, or perhaps both, have to be 0. So it's the same idea, where we split these up, and we say, okay, well maybe 3p equals 0, or 10p plus 7 equals 0, and then we just solve from there. So we get p equals 0 on the left, and p equals 7/10 on the right. Sorry, -7/10 on the right. Okay, so it's actually easier. I think it's just harder for students to see it, but the math is easier to do in those cases. One last thing. So speaking of GCFs, remember you're looking for both letters and numbers. And actually the letters are more important than the numbers in terms of solving, because it decreases the degree of your function. So here's what I mean. This first one only has a GCF of 3. So each term can be divided by 3. We pull it out front and divide to simplify what's left over and write it inside. Okay? If we look at this next one, it has a GCF of A. So I can divide an A out of each of these, but not a number. So I pull A out front and then get 14 plus 21A plus 21A squared. Right? Number 4 here has both, and that's probably the more common version. So if I look at just the numbers, I can divide a 4 out. If I look at the letters, I can divide an R out. So I pull that 4R out front, and then we're left with 3R plus 1. Okay? And then this goes back to that example I just showed. If I asked you to solve this, you would split this up. 4R equals 0, 3R plus 1 equals 0, and then solve both sides. Okay? Hopefully that's helpful, and we'll talk more about this coming up.